We have studied round robin scheduling algorithm last time. So whenever the clock interrupt is generated, at that time someone's microphone is on. Please mute it. Okay. So whenever the clock interrupt is generated, at that time the next process will be put in the running queue or running process. The next process state will be changed to running, and the currently running process will be kept in the ready queue. So based on the first in first out, one by one, all the processes will be given equal time slot. Whenever the time slot is over, at that time the next process will be given the chance. And this is a preemptive scheduling algorithm. We have done this example. Do you remember this? So please keep it with you. What have we done here? Time quantum is 4. That whenever any process is initiated, for 4 clock cycles, that will run and then the next will come. Here A was only for 3. So at that point of time, if any other process is available, then we will be giving it chance. If it is not available, then fine. And whenever from running, we are putting that process to ready queue, at that time, at the end, we'll be inserting that. So I hope that you are having this results with you. If you don't have, please write it down, note it down. For round robin example, whenever the time quantum is 4, at that time, finish time of A, B, C, D, E were respectively 3, 17, 11, 20 and 19. And this is the turnaround time. Have you all completed up to so far? Okay. So now we know that processor will be executing either a CPU bound process or an IO bound process. Whenever any IO bound process is running, then it will use the resources for some time and then it will be blocked. In the blocked state, it will be in the IO queue. Whenever it is coming out of the blocked state, then rather than putting that at the end of the ready queue, we are putting in the auxiliary queue. So we are having 2 queues, ready queue and auxiliary queue. When any process is admitted, it will be in the ready queue. Then it will be running. If it is a CPU bound process, then whenever the time slot is over, then it will be preempted and put back to the ready queue end. If it is a IO bound process, then whenever it is blocked, then it will be put in the IO queue. And if it is unblocked, then it will be kept in the auxiliary queue. Now processor will be giving priority to which one of these 2 queues? Ready queue or auxiliary queue? Auxiliary queue. Yes, auxiliary queue, because we want to reduce the bias towards IO processes, IO bound processes, because they are executing resources for the smaller amount as compared to CPU bound process. CPU bound process will be occupying the resource execution time for the entire time slot, while in this case, after some time it will be blocked. So we'll be giving first chance to processes if there is any in the auxiliary queue. If there is no one, then from the ready queue we will dispatch the process. So that is virtual round robin. Now I want you to do this example 0, 2, 4, 6, 8. The same example, okay? The same example. Now I want to calculate for time quantum 4. What is meaning of that? After each clock cycle, the next process will be given chance if it is available. Here the time quantum was 4. So when B starts, then for 4 time slots it will be occupying the processor. Then C comes, then C will be occupying for 4. Rather than keeping time slot or time quantum 4, if we are keeping it 1, will it change the performance or it will be same? Without calculating, can you just make? Yes, it might change the performance. And which one might be better? Time quantum 1 or 4? 4 means after 4 you are doing it. 1 means after 1, each one will be quickly changing. How do you say 4? Why do you think 4 is better? That is true. A less context switching. But then can I say 8 is better than 4? Let us make it 8, which will be better than 4. Can we say that? Then it might. Okay. So actually, we cannot say even in this example whether 4 is good or 1 is good until we find out the parameters. Similarly, we cannot say what will be the time for, you know, which will be better, 4 or 8. That depends on many parameters like the average service time, average processing time, then when they arrived, and how many processes are there, and so on. Anyway, I first want you to calculate a turnaround time, a normalized turnaround time, and finish time and response time whenever q is 1. Then we will compare them. Please start doing it. Please let me know whenever you think you are done. And there is no need to rush. Please try to get the correct answer. I hope you are drawing the diagram like this, the time progress diagram, like when which process starts, then which executes, then which one takes, and so on. Okay, please try to get it first and then only work for the response time, turnaround time, normalized turnaround time, and so on. First try to get this diagram, because if this is correct, then all other parameters would be correct. Yes, Priyank. A runs for one time unit, and if there is no other process available, then we will not keep the CPU idle, but we will give it to the process whichever is available. That is how CPU execution will be optimized. If there is another competing for the time, then we will give it the priority because A has already completed. But otherwise, if there is no one competing, then whichever is available will be executing. So everyone, can you tell me in the first time slot which process will execute? Be with me for 2 minutes, then again I'll give you time. A. In the second time slot, can you see the cursor where it is? Okay. A. In the third one, B. Yes, in the third one, B. Then in the fourth one, A. Then in the fifth one, B or C. In the fifth one, B or C. See, you will have to maintain the queue properly. Okay. Please maintain the queue properly, then only your answer would be correct. See. A. Look at this. This I'm giving you just for the reference for this one, because many of you thought it would be C while it would be B. And I want you to be able to grasp it from this. So once you understand that much, then please don't go through this. Try to do on your own. Have a look at this. That why here it is not C as some of you expected, but it is B. Just try to look at that. And once that much is clear, then please don't be greedy and try to see everything from this. You will go back to your book, do not look at the screen and try to complete the diagram. That is the way to learn. I just wanted you to prevent from misinterpreting the data. That is why I have intervened. Shubham, is it okay that here it should be B and not C? Okay. See, here it is A is the only process in the queue. At time is equal to 0, A is the only process. And then here it is the only process. When it is time B, then this arrives as well. B arrives as well. So we will give chance to B. Now B is going to execute total for 6 units. Only one we have executed. So 5 time slots are pending. So what do? We put that in the queue. We put that in the queue. That now A will be in the front of the queue and B will be here. At time quantum 4, what happens? C comes as well. So C will be pushed here. But already B is there. Whenever any process comes, you are going to insert that at the end of the queue, not in the beginning or in between. You will insert at the end of the queue. Okay. So this B will be executed and then C. Is the doubt clear, everyone? I'm just talking about first 5 time slots. Okay, then I'll go here because I don't want you to be uh, driven by the diagram. I want you to work on your own and get me the correct answer. Whenever you are done with this diagram completely, please let me know. Okay, can I ask one question and then stop? Uh, at what time all the processes would have completed the execution? 20. Yes, yes, it will be 20. Fine. Now please continue working and whenever you are done, let me know. I hope that all of you are working and not depending on others to work and write that it is done. Because others might be thinking pretty much the same. Then all of us will be waiting for each other. Okay, fine. Are you awake? Okay. Can I please interrupt again in the fifth one? Which one is, which process will be taking over in the fifth time slot? Okay. In the sixth one, okay. Seventh, seventh B. Okay. Then eighth, eighth we have some confusion. Some of you are saying C and some of you are saying D. Okay. And then ninth, ah, some of you are okay. Let us go back there. So the fifth one was B, and then C was already arrived. So here it is. C is given the priority, and then B. Okay, try to look at this. See, I don't think that analogy is required, but let me give you anyway. That one student is coming to me initially, student A, and all of you are coming to get your journals checked. You are writing the experiments and you are coming to get the journals checked. So what have I decided? That I'll check one experiment of all of you. Then I'll check the second experiment of all of you. Then I'll check third experiment one by one and so on. So initially A comes. So there is no one. So I'm checking the first experiment. And then I'm checking, is there anyone else? There is no one. So I'm checking second experiment of A. And A has written total 3 experiments. Now when I'm checking 2, then in the third time slot, another student B has already come. So I'll ask A to be in the queue. So now I have 2 students, B and A. So I'm checking of B and A is waiting outside my cabin, first in the queue. So B is executing. So after B's one experiment is done, I'll check third experiment of A. And when I'm checking of A, B is outside the queue. Meanwhile, C also arrives. C joins. Okay, C also joins. So I'll check of B, then I'll check of C. Okay, so when now A has already completed 3, so A will go to his home with the journal. And when I'm executing C here, then B is again kept in the queue. And meanwhile, D comes at C, 6. So D would be in the queue. Are you with me so far? Okay. So here it was which one in the queue? When B was executed, then B is removed from the cabin and he is in the queue. Okay. First it was C, then B, and then D. So when I'm interrupting C, C is waiting, then I'm interrupting B. So B was waiting and then D is interrupted. So D would be in the queue next. I hope this analogy is probably making some sense and it is making a bit easier for you. So D, C and B. Up to 10, if you have any doubt, then please ask me. Have you all understood up to 10? Anyone, any doubt? Feel free to ask me if you don't agree with any of these 10. I'll repeat. No, no one is in the auxiliary queue at the right now. All of these are CPU bound processes. All of these are CPU bound processes. They are not the IO bound. Okay, everyone please pay attention here. I'm repeating. Okay. These are the students. These are the times when they come for checking the journals and this many experiments they have written. The policy I'm adopting is I'll check one experiment and then time of the another one because we're assuming that I'll check unit time to check one experiment. So initially there is no one. There is a queue, okay? There is a queue. There is no one. So in the queue, who is there? Only A. So A, I'm checking one experiment. Now there are two experiments left of A. I'm again checking at time unit 1. પણ કેબિનની બહાર કોઈ નથી. A એક જ છે. So what will I do? I'll check the second experiment. Now at time unit 2, when I'm completing this, B arrives. So I'll ask A to please wait outside and I'm taking B over. So B is first and then A is waiting. I'm checking one experiment of B. Then what will I do? I'll ask B to go and A will come ahead. So A will come now. Okay. And B is already outside the cabin. Then C joins at 4. So C will be after B. So here B is given the opportunity and then C. Now A was already completed. So here after C, we are having B. Okay. Then D came meanwhile. D came meanwhile. But where was D? It was first C, B, and then D. Okay. So C executed. Then I'm executing B, and then it is the turn of D. Now look at here. C, I'm executing C. Is C over? No. Is B over? No. Is D over? No. I'm talking about this. The 6th, 7th, and 8th. Okay. After 6th, I'm completing. What are we doing? We are putting that in the queue. So first 6th is in the first C, then B, and then D. Now they are in the queue like this. Okay. C, B, and D. Because they are pending. One by one, they'll be kept in the queue. So this C is coming first. Then we are having this B. And when did E arrive? E arrived at 8. When did E arrive? E arrived at 8. So let us revise that. If E didn't arrive, okay, I'm ignoring E at the moment. If we are having just 4 processes, A, B, C, D, then can you tell me what will be the flow after this? If I'm having only 4 processes, A, B, C, D. So here it was C, B, and D. Then it will be B, C, B, and what will be here? D. Yes, it will be D. Then again, can you tell me what will be the next one? C. Then after C, B. And then after that, D. Okay, after that, C will not come now because execution of C is probably completed or not. If C is executed 4 times, then it will not come. If it is not completed, it will come. Anyway, I'm just trying to make one point is based on the arrival time and based on the queue, we are deciding which process will arrive. So this should be helpful to you at that point of time. That whenever it is time 7, at that time in the queue, we are having D, C, and B. Now at 8, this one arrives. So this arrives. And when D is completed, then D is put back in the queue at the end. And this is the sequence. Then C will be executed and C will go at the end. So it will be B, E, D, and C. Now once B is executed, if task of B is pending, it will go at the end and it will be E, D, C, and B. Now if E is interrupted, E will go at the end. It will be D, C, B, and E. Okay. Now this D will come here. And whenever E is executed 2 times, see here E is executed and here E is executed. It was only for 2 experiments, only 2 time slots. Then once it is completed, it will be removed from the queue. Is it okay? Do we have doubt anywhere? Are you all getting the same diagram? Okay. So can you tell me what is the response time for A? Response time for A? 0. Response time for B? 0. Response time for C, 1. Response time for D. How are we finding it? That it arrived at 6. And when are we attending? We are attending at 1, 2, 3, 4, 5, 6, 7. Where are we attending it? 6 and 7. Yes. So it will be 7 minus 6, 1. What is the time for D? Response time for D? D is 7. Sorry. E? E is, we are starting at 10 and it arrived at 8. So it will be 2. Okay. And completion time is easy, right? Completion time for A is 4. For B, what is the completion time? For B, finish time or completion time, that is 18. For C, it is 17. For D, it is 20. And for E, it is 15. Yes. And you can also find out the turnaround time for all the processes. So, are you getting this turnaround times? Sorry, this one. For Q is 1. Are you getting this turnaround times? 4, 16, 13, 14, and 7. What is the turnaround time? Turnaround time is when the process has initiated and when it is completed. The total time it takes to complete the process. Yes, finish minus arrival. So, are we getting 4 for A? Let us see. Okay. It completes at 4 and it arrived at 0. So, 4 minus 0, it should be 4. For B, it is completed at 18. 18 minus 2. So, it should be 16. Please confirm whether for C, are you getting 13? For D, 14. And for E, is it 7? Okay. Then, these are the normalized turnaround time. What is normalized turnaround time? Can you tell me? How do you find it? Turnaround time divided by service time. That is true. This is the turnaround time. Divided by service time is 3 in this case. This is 6. This is 2. For E, it is 2. So, for E, it is 7 divided by 2. So, it will be 3.5. And when you take mean of this, it will be the mean. So, these two systems, see, mean normalized turnaround time is same whether the time quantum is 1 or time quantum is 4. However, average turnaround time is different. Which one is better? Q is equal to 1 or Q is 4? So now the question which I'm asking is based on the parameters in the result which are available. For this example, if you are having these 5 processes with this processing time and this arrival time, which system is better if you do round robin like this or if you do round robin like this? For 4. Yes, it is good for 4. One parameter is reduced. Which parameter is reduced in case of Q is equal to 1? There is one parameter which is reduced in case of Q is equal to 1. Which one is that? Can you tell me? Yes. Just a second. Sir, lecture માં છું હમણાં અડધો કલાકમાં પતશે તો પર. Yes. Average response time will be reduced and starvation also will be reduced whenever we are going for time quantum 1. So let us say, if there is no parameters given to us that which one are we optimizing, then by default, between these two, this seems to be a better choice. But if it is given to us that we are looking for reduced or minimum average response time, then we will go for Q is equal to 1. Even though overhead is higher, because if we are looking for that parameter, then this one will be better. Anyway, here the performance difference isn't much higher because the service time were within range and all of them were available. But if there is drastic change in this and the arrival time might be different and more number of processes are there, then how much time quantum is to be given will be deciding the performance as well. Anyway, so is round robin very clear? I'm giving you time to solve the example because I'm afraid you might not do it if I give you an assignment. So I want you to do in front of me, virtually, of course, so that you will be very comfortable solving the examples. So we know two algorithms by heart now. Which are those two algorithms? Two scheduling algorithms we are well conversed with. First come, first serve, and round robin. These two we know. And we have invested sufficient time to be acquainted with all other parameters as well, the measuring parameters. Now I want you to be a little bit quicker, and can you try to do this exercise and tell me which one is better? Whichever parameter you want to do it and tell me. These are the processes. There are 6 processes: arrival time and service time. And time quantum, we have choice between 2 and 4. I want all of you to work a bit quickly, and this will be our last exercise in round robin. Then we will start the new example, new scheduling algorithm. Okay, tell me whether my statement is correct or not. For time quantum 2, for first time quantum P1 will be executed. In the second time quantum P2 will be executed. And in the third time quantum P3 will be executed. Is it correct? No, it isn't. No, 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 no. Can you correct it, please? First 3 time quantum, which processes will be executed? P1, P2, and then P3 or P1 again? Wait. For the first time quantum, it will be P1. Right? For the second time quantum, will it be P1 or P2? P2. જ્યારે નવી પ્રોસેસ આવી જાય ત્યારે તો આપણે એને આપી જ દઈએ છીએ, લાઈનમાં કોઈ જ નથી. P1 ચેક કરાવે છે, P2 આવી ગયા, તો પછી હું P1 ને એવું નહીં કહું ના ભાઈ તમે વહેલા આવ્યા છો એટલે તમારું જ ચેક કરીએ. We will not do that. Okay, we will take off P2, but now P1 is in the queue. P1 is in the queue at this point of time, and then P3 arrives. Okay, so for first 3 slot, can you please write me? P1, P2, and then the third one. What will be the sequence for first 3 time quantum, please? P1, P2, P1. Do you agree with that? Okay, please continue. Would you like to complete it now, or you can do it afterwards and I can start the another scheduling algorithm? Whatever you prefer, I'm fine with both the ways. We will be able to manage it. Do you want to finish this, or do you want to skip it at the moment and do it later on? Okay, please continue. Yes, those who want to continue, please continue. Those who want to complete later on, please do. Have you all noted down this table? Then I would like to scroll to the earlier example for Bhavik. Have you all noted down this example in your book? Can I please go to the previous slide? Okay, please note down. Urjit, make it fast. So I'll change it. Okay, so Bhavik, let us look here. Okay. A arrived at 2. Sorry, 0. A arrived at 0 and B arrived at 2. Others can continue with that example if you don't have doubt. So, in the first time slot, from 0 to 1, that is the first time slot, 0 to 1. If we are assuming that we are starting at 0 time, then from 0 to 1, there is the first time slot. There is no process available. A is the winner. A will be given the slot. At 1, is there any other process available? No. At 1, there is no process available. Only A is available. So, we are giving time to A. Now, from 1 to 2, that means at 2 time slot, B arrives. Okay, B arrives. So, now B is in the queue first and then A. Because A has already got its chance. We were executing A because there was no one available. But now B is available. So, rightfully, we will give chance to B here. Do you agree with this? That from 2 to 3 in the third time slot, when it arrives at 2, then from 2 to 3, B will be given the chance. Bhavik, do you agree here? Or we have any doubt here? Huh? In time slot? In time slot 4, A will come. Okay. Then in time slot 4, A will come. Because here, see, no. Because, see, A was executing in 2 at this moment. At 2, what did I decide? At 2, I have decided that B will be executing. And who is in the queue? A is in the queue. We don't know that C will come. Currently in the queue, who have we kept? In the queue, we have kept this. B is executing and A is in the queue. Do you agree with that? See, assume that here I don't know how many students are there. A was getting the channel checked. B arrived, so I'm checking of B. And what am I doing? I'm asking A to please wait. I'm saying that A, you please wait. So A is waiting. Now here at that moment only, when A was waiting, when is A kept waiting? Here, after 2. Then at 4, you are getting, or tell me, where is this? Is the first time slot key clear here? Bhavik, in this one, is first clear? A. Okay, second one, A clear. Then third one, B. Is it clear? First 3. Okay, then see, here is not time slot 3, time slot 4. But when does it begin? It begins at 3. 3 to 4 is denoted at 4th time slot, 3 to 4. Is C available here? No, C is not available here. Is C available here? No, it has not arrived. It is 3. See, 0, 1, 2, and 3. At 3, there is no one available. Which one is there? A was in the queue. So I'm giving chance to A. And which one is preempted? B. So I'm asking B to wait. So in the queue, we have B. And now, when I'm completing here, at this moment, at 4, C is coming. So in the queue at 3, T is equal to 3. In the queue, we have B. A is executed and B is in the queue. Now at 4, B is already in the queue. A was executed and A gets over at 4. And when C arrives at 4, it will naturally be after B. C will be after B. Are you getting that? See, 4th time slot is different and time is equal to 4 is different. Is it clear? Please feel free to, you can unmute yourself and ask me also. If you have any doubt, you are unable to explain in the chat window, you can ask me.
Like ma'am, like first time slot 1, A fine. Like in 2, like we are giving priority to the B.
See,
That's
no,
okay.
not in 2. In the third one, not in 2. It is 0 to 1 is first time slot, 1 to 2 is second time slot, and 2 to 3 is third time slot. Now tell me.
Okay, got it.
Yes?
Yeah.
Okay. Please still go through that once again, and afterwards also, if you have any doubt, you can approach me. Okay, is there anyone who has completed time quantum 2? Can you give me the response time for this 6 process for time quantum 2? Okay. I know probably I am hurrying you unnecessarily, but I just want to ensure that you are on the right track. Okay, so Chintan says, if the process has completed execution and being sent back to wait, and at the same time a new process is entering, then which one will be the, see, if it has completed the execution, then we will not put that in the wait state. If it is preempted, then we will put it in the wait state. If it has completed, then it will no longer be in the ready queue. Okay. If it is preempted, then What do you think? Which one will be there? Not you in general. That is okay, Chintan. I was just trying to use the correct terminology. I understood what you wanted to ask. So if any process is preempted, what he's saying is that if you are preempting, for an example, one process at 7, one process we are preempting at 7, and at the 7 only, if P7 is coming, then that process which are preempting Px, should that be ahead or P7 be ahead? Would anyone like to answer? The question is that Px process is being executed at the moment. Okay. And when the time slot is 6 to 7, at the 7, I'm preempting P7. Let us say P7 I was executing, I'm preempting that. And the new process arrives at the very same moment. Then in the ready queue, will I keep the process which is preempted or the new one? Actually, there is no one correct answer, That depends on the implementation in your algorithm. That depends on your implementation. If you chose to have the variant of this algorithm which says that new one should be ahead, then it will be that. If you choose that the older one should be first finished and then new one will come, then it will be that. And actually round robin in the plain format which we are learning will rarely be used. Round robin will be used with something else and then it will be used. Most of the time, round robin and first come first serve are the algorithms which are not generally used. So this depends on the implementation. Yes, if implementation is not specified, then you may have that. But most of the time, the examiner will ensure that you will not be in this type of dilemma. But if it is not specified, you may have. I don't know actually, Juzar, because I haven't calculated that. When P1 is completed for the first time slot, P2 and P3 both arriving. Are you saying both arrives at the same time moment? P2 and P3, if both of them arrives at the same time moment, that is what you are saying? No, but at the end, both are present. Birva, are you saying that one process is completed? Like here, are you saying it is one here and one here also? P2 and P3, both of them are having arrival time 1. Is that what you are suggesting? When P1 is completed for the first time slot, P2 and P3 both are arriving. Okay, then whichever arrived first. Okay, you are saying that when it is, what will be status of the queue? At what point? In this example only, or you are suggesting a different example? In this example only. Okay. So at 0, in the queue we have P1. At P2, at 1, P2 is executed and in queue we have P1. In the queue we have P1. At 2, P2 will be executed. In the queue we have P1 and then P3. Is this what you are asking? Okay. So I think I'll stop at the moment. Please try to get response time for all of this. Kevin has written that. Is that true? 0, 1, 2, 5, 5, 7. Is it true? Are you all getting that? 0, 1, 2, 5, 5, 7. Okay. Okay, Rikin. And for, okay, Yash has also got for Q is equal to 4. For time quantum 4, the response time are 0, 3, 6, 7, 7, 9. Is there anyone else who is getting this? Anyway, I think it is your lunch time and probably you are hungry. So I want you to find out response time, turnaround time, normalized turnaround time, finish time, and average of them, and then compare it and see whether you can come to a clear conclusion. First, we will attempt this in 1 or 2 minutes in the next class, and then we will start another algorithm, shortest process next. That I intended to start today, but that is okay. We'll do it tomorrow. I'm ending the meeting.